Today we're going to be talking about the second derivative test. We've already done the first derivative test, and we've talked about how the first derivative can be used to find increasing, decreasing intervals and your relative maximum and minima. And then the second derivative can be used to find your intervals of concavity, so concave up and concave down, and your points of inflection. So we've already kind of talked about the second derivative, but we can actually also use the second derivative to help us find relative maximums and relative minimums. Okay, so another little kind of use for the second derivative, don't get the second derivative test confused with using the second derivative to find concavity and points of inflection. That's the only thing that can get a little confusing here. Okay, so the second derivative test, find the first derivative, find your critical numbers, find the second derivative, evaluate each critical number in the second derivative. So we're going to find our critical numbers on the first derivative, and then we're going to plug those critical numbers into the second derivative. If when we plug in, we get out a positive number, then our value is a relative minimum. So it's like the opposite of what we get out. So if we get out positive, it's a relative minimum on f. If when we plug into the second derivative, we get out a negative number, then it is a relative maximum. So let's look at an example here, number 4. Okay. Find the relative extrema for f of x is equal to negative 3x to the fifth plus 5x cubed using the second derivative test. So first derivative, f prime of x is equal to negative 15x to the fourth plus 15x squared. Okay, we can set that equal to 0 to find our critical numbers. Factor out a 15x squared. And we get x equals 0, x equals, that would give us positive negative 1. Okay, then we want to find our second derivative, so f double prime of x equals negative 60x cubed plus 30x. And then we're going to plug all three of our critical numbers into the second derivative. So I want to know f double prime of negative 1, f double prime of 0, and f double prime of 1. Okay, so plugging in negative 1 cubed will be negative 1. Negative times a negative is a positive. So 60 plus 30 times negative 1 will be negative 30. So 60 minus 30 is 30. Okay, plugging in 0 and 0 would just give us 0. Plugging in 1 would give us negative 60 and positive 30, which would give us negative 30. Okay, so those are our values on the second derivative, plugging all these numbers into the second derivative. Now, using our second derivative test, if my value is positive on the second derivative, then C is a relative minimum. So it's the opposite. If it is negative, then C is a relative maximum. And if we don't get either, it's neither. Okay, so let's look. So 30 is positive, so I would say x equals negative 1 is a relative min. 0 is 0, so it's nothing. And then 1 is negative, so it's opposite. So x equals 1 is a relative maximum. Okay, so you be the judge. With second derivative test, I mean, you don't have to use it over first derivative test. You don't have to use first derivative, or you don't have to use first derivative test over second derivative test. Use whichever one you like, okay? So if you like this, you're like, oh, wow, that's so much easier than plugging in for test intervals, then awesome. If you're like, Mr. Arbone, why would I do this if I have the first derivative test? Then fine, don't worry about it. Up to you, okay? It's a skill, giving you more skills. Number 5, find the relative extrema for f of x is equal to negative x minus 5 squared using the second derivative test. So once again, f prime of x is equal to, squared comes down, so negative 2x minus 5 times derivative of the inside would be 1. So f prime of x is just equal to negative 2x minus 5. Set that equal to 0. Okay, only x we have is on the inside, so we get x is equal to 5. Okay, take our derivative again, f double prime of x equals negative 2 would stay negative 2. This becomes x minus 5 to the 0 power, okay, because this was a 1, this is now a 0. And then I derive by the derivative of the inside, which is 1. Anything to a 0 power is 1, so f double prime of x is equal to 1 times negative 2. So it's just negative 2. That's an easy derivative. So now if I want to do f double prime of 5, hey, well, everything on f double prime is equal to negative 2. So since I got negative 2, negative means relative maximum. So x equals 5 is a relative maximum on f. All right, one last basic one. Find the relative extrema for f of x is equal to x to the fourth minus 4x cubed plus 5 using the second derivative test. Okay. F prime of x is equal to 4x cubed minus 12x squared. Set that equal to 0. Factor out, looks like we can take out a 4x squared. So x minus 3. So that gives us x equals 0 and x equals 3. Then we take our second derivative, so f double prime of x would be equal to 12x squared minus 24x. Then we're plugging everything in, so f double prime of 0 would be equal to 0 and 0 is just 0. F double prime of 3 would be equal to 3 squared 9 times 12 is 108.
Teachers.
And then 24 times 3 would be 72, so minus 72, which would equal about 36, which is positive. So 0 is nothing, but 36 is a positive, which means x equals 3 is a relative min. So the nice thing is you don't have to, find out those test intervals, plug in random things. You're always plugging exact critical numbers into the second derivative when doing the second derivative test. Okay, so those are kind of your basic. Here's the thing, use the second derivative test. Okay, number 7 is a question you might see on the AP exam. Okay, let f of x be a polynomial function such that f of 3 is equal to 8, f prime of 3 is equal to 0, and f double prime of 3 is equal to negative 4. Is the point 3, 8 a relative minimum or a relative maximum of f of x? Okay, so the information we have is that it's some value on the original function, 8. It's equal to 0 on the first derivative. So if it's equal to 0 on the first derivative, then that means 3 is a critical number. Okay, so if it's a critical number, I can plug it into the second derivative and use the sign of the second derivative to determine if it's a maximum or a minimum. Okay, so they also give me that f double prime of 3 is equal to negative 4. So f of double prime of 3 is equal to a negative number, which means it would be a relative maximum because opposite sign is the second derivative test. So x equals 3 is a relative max. So this would be a question, which this is a real AP question that you could see as multiple choice, where you have to know the second derivative test to be able to solve this question. Okay, so that's the only time where they don't give you enough information. I can't plug into my test intervals on the first derivative where you would have to use the second derivative test. And they will throw one of those out there at you every once in a while. So just, be prepared, be ready for it. Last thing we're going to do today, y'all, is we're going to go, kind of from what we did last class and what we're doing today. We're going to go through all of the things, but I want you to both see it graphically and algebraically. So given the function, f of x is equal to x cubed over 4 minus 3x squared plus 9x minus 8 over 3, we're going to graph f, f prime, and f double prime and list all relative extrema and intervals. I've given you 3 little graphs there. So I want you to graph all of them. You can use your Desmos calculator. You can use your TI-84 to help you graph these. Go ahead and pause me so you can graph them first. And then once we graph them, we'll talk about all that important stuff, okay? All right, y'all. So you should have gotten these 3 graphs for f, f prime, and f double prime. Yours might not look quite as exact like mine, okay? But they should be pretty close. Use this moment maybe to, check up. You should have at least gotten the correct first derivative and second derivative. First derivative is equal to 3x squared over 4 minus 6x plus 9. and second derivative would be 3x over 2 minus 6. Okay. Now, what I'm going to point out is we're going to kind of go through our graphs, and we'll start with the original function and then kind of work our way through the first derivative and the second derivative to get all that relevant information. And I want you to see how those connections exist through the three, through f, f prime, and f double prime. And if y'all need to, you can type these equations, our original f of x equation, f prime equation, f double prime equation. You can type all of them into Desmos, but I don't want you to focus on being able to graph these by hand because that's really not the important here. What I want you to focus on is being able to get all of our information, all of our increasing, decreasing, max, min, concave up, concave down. And I want you to see how these graphs connect to each other. Okay, so we're going to start with the first piece of information on f, and that's when f would be increasing. Okay, and our increasing, if we remember, okay, that was our upward arrow. So when is f increasing? Well, f is increasing when our f prime graph is positive. So let's look over at f prime. So f prime is positive. I'm going to change this real quick. So over on our f prime graph, we can see pretty clearly that from about 6 onward, our graph is positive, and from negative infinity up to 2, our graph is positive. Okay, so that same, where f prime is positive, f is going to be increasing. So over here on f, we can see from 6 onward, our graph is increasing, and from negative infinity all the way up until 2, our graph is increasing. So down here, we're going to add in the interval. F is increasing from negative infinity to 2 in union with 6 to infinity. Okay. Then from there, we're going to add in decreasing. So our f is decreasing when f prime is negative. So f prime is negative from 2 to about 6. And we can see over on our f graph from 2 to 6, ooh, not that, we are decreasing in value on f. Our y values are going down, so that matches up. So from 2 to 6, we are decreasing. Okay. Now, the next thing is in between our increasing and our decreasing would be our relative maxes or our relative mins. So we can see pretty clearly here we have a relative max at 2. We can also see on f prime, okay, because relative maxes occur when f prime changes from positive to negative. So on f prime, right here at 2, we go from positive to negative. So we can see that match up. So relative max at x is equal to 2. Okay, and then our relative min would be here at 6. And once again, relative mins on f occur when f prime goes from negative to positive. Right here on f prime, we go from negative to positive, so that also matches up. So we have a relative min at x equals 6. All right. Okay, after we do our increasing, decreasing maxes and mins, the next one is our concavity, concave up, concave down. Okay, concavity on f is when f double prime is positive or negative. So when f double prime is positive, f is concave up. So let's go over to f double prime. F double prime is positive from 4 onward. So that means our f graph should be concave up from about 4, oop, not that, from about 4 all the way around, which that lines up. We can see that U shape from 4 all the way onwards, that upward U shape in our graph. Okay, so down here, concave up interval would be from 4 to infinity. Okay, now concave down on F occurs when F double prime is, I'll do yellow. Concave down occurs when F double prime is negative. So F double prime is negative from negative infinity until 4. Boop, just like that. And we can see over here on our graph, from that same value of 4 all the way to negative infinity, we do form that concave down, that upside down U shape on our graph. So down here, concave down from negative infinity until 4. Okay, last piece of information that we've been pulling is points of inflection. So we just look at our concavity change. We do have that concavity change between negative infinity to 4 to infinity. So right here at 4, it's hard to see. And also, I'm not the best drawer in the world, but we do switch from concave down to concave up right there at x equals 4. And that lines up with on F double prime right at 4, we have a sign change. Remember, with points of inflection, it doesn't matter positive, negative, negative, positive. We just have to have a sign change. So we are having that occur. So our point of inflection would be x equals 4. Okay, so that's all of this relevant information on F. Okay, on F prime, let's see how some of the same information matches up. So where F is increasing or decreasing, F prime is positive or negative. So F prime is positive on the interval negative infinity to 2 in union with 6 to infinity. And we are negative on that interval 2 to 6. So notice how positive lines up with increasing, negative lines up with decreasing. Okay? Critical numbers on F prime mean relative maxes and mins on F. So critical number at x equals 2 and x equals 6. And remember, critical numbers are when F prime is equal to 0. So we can see F prime is equal to 0 here at 2 and here at 6, which lined up with our relative maxes and relative mins on F. Now, remember, not all critical numbers necessarily become relative extrema, but in this case, both of them were relative extrema. Okay. Then, last but not least, okay, F prime, just like F is increasing, decreasing, has concavity, F prime also is increasing, decreasing, and has concavity. So I want you to notice on F prime, okay, F prime is decreasing from negative infinity all the way until what it looks like to be about 4. Oop, not a square. Don't even know why I clicked that. So F prime is decreasing from negative infinity all the way until about 4 right here, which lines up with where F double prime is negative. So where F double prime is negative, F prime is decreasing in value. Okay, so down here, F double prime is decreasing. Oop. From negative infinity to 4. And F double prime is increasing from 4 all the way to infinity, which lines up with when F double prime is positive. So that positive increasing, negative decreasing lines up with F double prime and F prime, just like it lines up with F prime and F, which makes sense because F double prime is the first derivative of F prime. Okay, so adding that into our important information down here, We are increasing from 4 to infinity. Okay. Now, with that, increasing and decreasing, where we had that switch, okay, just like increasing and decreasing switches on F create relative maxes or mins, increasing and decreasing switches on F prime create relative maxes and mins. So what do we have right here at 4? Well, 4 on F prime is a relative minimum. So our F prime graph has a relative min at x is equal to 4. Okay, and it's a relative min because we changed from decreasing to increasing. And on F double prime, we went from negative to positive. So that same relationship creating relative mins happens on F prime. Okay, hopefully by now y'all are starting to notice how things are lining up. Okay, and we even have on F prime is concave up, which it's that nice parabola shape, but it is concave up for the entirety of its graph. Okay, so I could say that it is concave up from negative infinity to infinity. Which you notice the concavity of F prime shares no similarities with F. Okay, so we're going to see, hopefully by the time we get to F double prime, we're going to see this 3-tiered relationship, but eventually that tiering does break, and we're going to talk about that a little bit more here towards the end of the notes. Okay, but concave up from negative infinity to infinity, and because we're always concave up, we're never concave down, and because we're always concave up, we don't have any points of inflection. Okay, so now let's finish this up by talking about F double prime. Okay, so F double prime is positive from 4 all the way to infinity. So where F double prime is positive, F prime is increasing and F is concave up. So that lines up right here. So F double prime is positive from 4 to infinity. And F double prime is negative from negative infinity to 4, which lines up with decreasing and concave down on F prime and F. And then on F double prime, we have a critical number where F double prime is equal to 0 right here at 4, which was a relative minimum on F prime, which was a point of inflection on F. And then last but not least, F double prime is increasing along its entire graph. Okay, so since it is increasing the entire time, it would actually be increasing from negative infinity to infinity, which, look at that, also lines up with concave up on F prime. Okay, so hopefully y'all, as we work through all of these, you've started to notice where the similarities, where the lineups here. So I want you to see a couple of spots. The big one is this concave down on F, increasing, decreasing on F prime, and positive, negative on F double prime. That's the big tiering of relationships. So we also have that relationship between increasing, decreasing, positive, negative on F and F prime, and increasing concavity between F prime and F double prime. So all of these relationships, they tier. F prime, and F double prime. They're all related to each other. These same things tier up as we keep working through our derivatives. We could keep going to the third derivative, the fourth derivative, the fifth derivative, and we could keep finding these relationships. To help organize all this, because you're probably like, Mr. Abone, I'm like mind blown right now, and you've jam-packed too much information into my brain. Okay, we're going to fill out what's called the calculus house. This is the other notes page that I gave you. So here in the calculus house, okay, over on the far left, this is going to be F prime, F double prime, and sorry, I got too zealous with my primes. Capital F prime, F double prime. Okay, we want to add down here a little key so that we don't forget what everything represents. F is the integral, which some of y'all have asked already. Integrals is chapter 5. We're going to talk about it in the spring. F original, not prime, is our function. F double first prime is our first derivative. F double prime is our second derivative. Okay, and we're going to start by filling out all of our important information so we know when F is positive and negative, increasing, decreasing, and concave up, concave down. So we've talked about all that information before. So now we can add in what all of these symbols mean, which you'll probably remember, but just in case you ever forget, just as a recap, positive, the plus sign means positive. Negative sign means negative. Upwards arrow means increasing. Downward arrow is decreasing. Uppercase U is concave up. Lowercase or upside down U is concave down. All right, now we've talked about this already before. Okay, we know F is increasing when F prime is positive. We know F is decreasing when F prime is negative. We know F is concave up when F double prime is positive. We know F is concave down when F double prime is negative. Now what we just discovered is when F double prime is positive, we also know that F prime is increasing. When F double prime is negative, we also know that F prime is decreasing. Then we also know when F prime is concave up, F double prime is increasing. That's what we discovered there on our last graph, which I think it would serve to know that when F double prime is decreasing, F prime is also concave down. You starting to see the pattern? Okay, so we can just fill in the rest and then we can work backwards to our integral, which hopefully you've maybe picked up on this a little bit. Integrating just means to go the opposite directions from deriving. So deriving goes from F to F prime to F double prime. Integrating would go the other way from F double prime to F to capital F, which is actually representing our integral of F. We'll talk about that more later. Don't worry about the integral for now. The biggest relationships that I want you obviously to see, okay, right here, positive, negative, increasing, decreasing between F and F prime. Then our big one here, okay, look at all this information we can get about F, F prime, and F double prime. And then this last grouping between F prime and F double prime. Okay, that's the biggest, that's the meat of our calculus house. But this is a really good way to help you remember all of your relationships between F, F prime, and F double prime. You can write this on the top of your papers. You can have this out on a note card, anything to help you keep track of all these different relationships, y'all. But that is the second derivative test and a little bit extra. But if you have any questions, y'all, feel free to ask me in class.